In this video, I will show you how to build and fine-tune your predictive models inside Model Studio. So from the upper left menu, you can select Build Models, and that brings you to Model Studio. And here, you start the modeling by selecting a new project and giving it a new name. And you can leave the template as blank and just select a data source if you wish. And let's use the same HMEQ dataset that we have been using previously, and hit OK. And as I create save, the project is created and launched for me. So the first step is to set the roles in the data. So I need to set the inputs and the target. And I can do that after the data is loaded to the project. Alright, here we go. So this is the same data. So the variable bad is the binary variable we want to use as a target for the prediction. So is the loan repaid or not? So that's the thing we want to predict. So we set that as a target. And otherwise, I think the data looks good. So the rest of the variables are defined as input. After that, we can jump to the Pipelines tab and start building our modeling flows. Let's take a look at what kind of nodes we have here. So we have pre-processing nodes that we can use to modify the data and for example, do feature extraction, filtering, imputation, transformations, for example. And then we have different supervised learning nodes. So here you have the standard nodes like linear regression, logistic regression, gradient boosting, neural networks. And you can also save your own if you want to use open source or SAS code. And then under miscellaneous, you have also the option to score data. So once you have developed your models, you can score new data here if you want to. You can do some data exploration, and again you can do, for example, a SAS code node where you can then code your own nodes and build anything basically you want on top of the ready-made nodes. All right, but let's start simple and drag and drop a logistic regression to the canvas. And once I do that, I get the simplest possible Model Studio flow here. So we have the data node, the model, and a model comparison. And let's build it a bit more complex. So another option could be that we want to do some type of data pre-processing. And another way to add actually the nodes is by right-clicking the nodes and adding a child node here. So let's do a pre-processing node of a type feature extraction, and that is added to the canvas as well. And in this case, let's try a gradient boosting node as addition here. So now I would have two models competing each other for the best accuracy. And on the right here, I can adjust the settings. So let's turn the auto-tuning on for gradient boosting, and then we have different types of settings for that as well. So different minimum and maximum values the machine would try for auto-tuning the best possible parameters. You might want to adjust maybe the maximum time setting or other maximum limitations to limit the time the machine will try to get the best possible parameters. And in the bottom here, you can find also the model interpretability options. So these are quite nice and I recommend to try them. So it's easy to turn them on. Just click on the boxes here. So we have partial dependence, eyes, lime, and SHAP methods here that you can use to understand your models a bit better in case you are using the more complex models like gradient boosting or neural networks maybe. Then we could add a third option here. So for credit scoring, we have this interactive grouping node, especially made for that. You can use it for other purposes as well, but typically it's used in credit scoring. And that gives us some nice way to group interval variables into different types of bins. And we will look at the results a bit later, so you can understand how it works. And after that, we can add a node from the miscellaneous tab, and here is a scorecard node, and this is basically a logistic regression node, but there is it's a simplified way of understanding how the logistic regression works. So it builds a scorecard that is easy to understand for the business users, and you can use it to determine whether an applicant should be granted a loan or not. So there's a simple score threshold that can be used to do that decision. And let's move the node to supervised learning. So the Model Studio understands that we want to compare these three models. Now I have everything ready, so I can just run the pipeline and get the results. The pipeline is ready, so let's take a look at what we got. We can start by checking the model comparison and seeing the overall results. And this gives us the comparison between the different algorithms. So it seems that the gradient boosting algorithm narrowly came on top this time. Obviously, we didn't adjust too much of the settings, so we could still fine-tune the models a lot. But yeah, it seems that we got decent results. And here we see different accuracy measurements like KS, and other ones like Gini measurements. And we can take a look at the assessment also for some plots for the results. If we want to take a closer look, we can always check the individual node results and look at the details here. And for example, for gradient boosting, we have the variable importance here, so we know what kind of variables were selected. So it seems that some of the principal components we made with the feature extraction node have been selected, for instance. And here you see more of the statistics here. The thing I want to show about the gradient boosting is the model interpretability tab. So for gradient boosting, we turn these on. And for example, I will show some of these. So here we have all the variable importance again, and then also partial dependence, eyes, lime, and SHAP plots that you can use to understand your model a lot better. So let's take a look, for example, for the partial dependence, I can take a look at, for example, how the different job categories affect the predicted risk of the loan. Okay, let's close this and check the scorecard flow. So for the interactive grouping, I can adjust the groups manually if I want to. And handy way also is to use the manage group bins view also to check the results, how the interactive grouping has worked. And here I have a nice visualization of the different variables. So for example, here I have the debt to income ratio and how it has been cut off to different bins and what's the weight of the evidence for the different bins, and on the right you see then the averages, and I can show the other ones as well. So here are different options we have for all the variables. Okay, but this looks good. So I can jump to the results of the scorecard. So here I right click the node and I get the results tab here open. And here I see the different parameter estimates. So I'm using the weight of evidence variables created by the interactive grouping node as the inputs. And here I get important statistics like chi-square for the different input variables. If I scroll down, I get even more results that I might want to use for interpreting the model. And one thing I like is the scorecard table here that shows how many points the scorecard points are created by the different bins. So this helps me understand what actually is the risk level of different variables. So a good example might be the debt to income ratio. So if the debt to income ratio is very high, in this case it produces a low amount of points, and if it's very low, then we get a high number of points for the scorecard, meaning that if the applicant is should be granted a loan, there should be a lot of points. And you can always reverse that if you want to do it the other way around, so that bad applicants get a lot of points. I can also take a look at the assessment. And here I get more information about the information value, for example, for different variables. What is the cumulative event rate compared to the cutoff score, for example, and what's the average predicted probability compared to different cutoff scores, for example. So a lot of information I can use to understand how the scorecard works, and all the different important statistics related to the model. So the next step would be to either register the model I have here, or I could also add another pipeline here and build maybe some type of another modeling strategy and try out if I get a better result, and compete those models against each other. So the idea is that I get the champion from each of the pipelines, and then finally in the pipeline comparison tab, what we will take a look at in a second, all the champions from the different pipelines will then compete against each other. So it's the champion of the champions that is finally selected. And here, if I would like to, I could also try to generate the entire pipeline automatically. So I could set a limit of maybe 15 minutes and let the machine do the work and search for different types of pre-processing steps and modeling algorithms that might produce the best result. And usually that gives a good baseline that you can use as a starting point for your own modeling adjustments then. So the last step would be to take a look at the pipeline comparison tab. And here I have the champion model from each of the pipelines available, and then all the models as well that I have manually registered as a challenger. So for example, I have right-clicked the scorecard node and added that as a challenger to the pipeline comparison. And here I can take a final look at the models and what's the best one maybe. From this little icon, I can adjust comparison metrics if I want to. But I'm happy with these models. So the next step would be to register them. And if I select them all, I can also compare them, but in this case, I just want to directly register them to the centralized model management. And it takes a while, but pretty soon the models are registered and we can jump to the next phase of building the decisions and publishing the models and getting results from them through REST APIs. There we go. Both of the models have been now registered. And the cool thing here is that we are not actually registering just the model, we are registering the entire modeling flow. So in the case of gradient boosting, we are actually registering the principal component calculation as well. So it's really easy now to take the model into production because the entire flow is encapsulated in that model we register.